So what we're doing today, this is day 4. We're going to look at this text message kind of activity. We're going to look at piecewise defined functions. And the two questions that you're going to be thinking about today are in what situations is function notation more useful than using y equals? And the other one is what kinds of graphs are easiest to describe with set notation and interval notation? Okay? Think about that as we go through today. Now, my goal is to get through all of these notes to give you 3 problems where you'll get bonus points with group work together. And hopefully, if we have the time and we can progress through, do 2 of your homework problems on video as well. Okay, here we go. So, let's look at this activity of this text message. Alright, so here we go. It says Veronica has a cell phone plan where she pays $29.90 per month for unlimited calls and up to 500 text messages. So she does not have unlimited text messages. She just has unlimited calls. However, if she goes over this, as far as the text message, she will be charged an additional fee of 10 cents for each text that she sends. Okay? So, let's go ahead and look at the table of how we build this. And we're going to start by putting the texts, where the number of texts are right there, which is our x input variable. And we're going to put the monthly bill, which is our y output value, which is what you see there at $29.90. Now, in math, and sometimes when you're taking notes the way you are now, sometimes the teacher or the professor might go a little fast. And if you have to repeat certain things, like this right here, from what we read, is going to be here, here, and here. Now, we don't have time to write included in plan because we're not being efficient. What I want you to do is, if you put these like quotation diddle marks, it basically tells you and yourself, when you go home and you're reading your notes, whatever belongs here is a carbon copy of the line above. So there's a strategy for taking notes, okay? If you have some things that repeat, just do the diddle marks. So these diddle marks are going to exist all the way to 500. Saved us some time. And that's what I'll do for the rest of the year, okay? So $29.90 is also going to be the same. Or if you want to put a line and show it like this, that's good enough for me too. Alright, so now at 501, it's going to change. It's not going to be $29.90 anymore. Okay? So someone tell me, how did they get 30?
Because it was 10 cents extra for the next text.
It was 10 cents extra for this one text, right? So here we go. We start at $29.90. We add 10 cents for one text. Okay? Now, how about if it was $5.25? How many extra texts anyone do I have? 25. Does everything else stay the same? Yeah. So we're going to put 25, and we can go ahead and write it out or put diddle marks. I'll write it out one more time, and then I'm going to put diddle marks. So 10 cents, you can use your calculators, times 25, because there's 25 texts. If you add it all up together, what would be the total? No, like the total for the whole cost. $32.40, right? So $32.40 is the total, because remember we're at $29.90. Okay? So here we go. I'm going to put diddle marks, because that doesn't change. But the important thing that I'm trying to see is what's in the next parentheses. Anyone? 150. The next one? 450. And the last one? 700. Nice. Now, I will save you the time, but putting this into the calculator, we will get $44.90 we will get $74.90, and we will get $99.90. Questions so far? Okay, so what I want to do now is we're going to graph the data so that it'll help set us up for the piecewise functions that we're learning here soon. Okay? So, let's go ahead and graph these points as an input x-axis of number of texts and a y value of the monthly bill. Alright, so as far as the x is concerned, I don't want a messy graph at all. Okay, so let's say each of these lines on the bottom is 100, but we're only going to label 200, 400, 600, 800, okay? So let's start at the second one, and we're going to put 200, 400, 600, so it's a little bit cleaner, 800, 1,000, and 1,200. Then we're going to go to the bill. And each line is going to be 5. So let's skip the first one and go to 10. And then skip 20. Skip 30. So on and so forth. So we have a cleaner graph. Otherwise, it'll get messy really fast. 70, 80, 90, and 100. Okay. Now we're going to start plotting points. And what we're going to do is what you did in Algebra 1. The x and the y, 250, 2990. So I find 250, which is about here. I go up to 2990, which is about there, and I put a point. And you're going to do this all the way to 500. So for the sake of time, I'm just going to go all the way to 500 and put 2990. Now you tell me, what if x was 0? What would it be? 2990. So at 0, 2990, on the y-axis, that's where we're going to start. Now what I want you to do now is, since they all stayed the same, we're just going to draw a nice horizontal line between those points. Okay? Now we're going to draw the next parts to this graph. Okay, we're going to draw 501 at 30, which is really, really close. We're going to draw 525 at 3240. So 525 is about here, 3240 is about here. And yes, you can jump around because this is all linear. It's all growing at the same rate. So you know it's going to be a line because they're all growing at that 10 cents for each one. So let's jump all the way to 950, and we're going to graph 7, so 950 is about here. We're going to go to just under 75. And at 1200, we're going to go just under 100. So that if I do a line, it'll look something like that. Now, let me ask you, should I put an arrow here, or could I put an arrow there, yes or no? Yes, I can. Because I could continue to text forever, and my bill is just going to keep going up. Your parents won't appreciate it, but it is possible. Could I put an arrow here? No, why not? Why can't I put an arrow there? Because it's going to be, not because it's always at 2990, but because I can't have a negative amount of text. Okay? So you can only start at 0. Alright. Any questions from what we have so far? Yeah. So, here we go. Let's move this up. You know what the graph looks like. And you tell me, from the graph, what was the domain that you saw in interval notation? Anyone, where did it start? It started at 0 and it went to infinity. So here we go. 0 to infinity. Anyone? Bracket or parentheses on 0? Bracket. Nice. Parentheses or bracket on infinity? parentheses, always. Good. What's the range? What is the range of those y values on that graph? Anyone? 2990 is where we start. Parentheses or brackets? Bracket. All the way to what? Infinity. Now, for extra practice, what we're going to do is we're going to draw it in set notation. Because if you could do set, you can easily do algebraic. So here we go. It will be the set of all x's such that x's are greater than or equal to 0. Okay? The other one will be the set of all y's such that y's are greater than or equal to 2990. Okay? Now, you're looking at the graph. I know I don't have it pulled up right here, but you can see it on your paper. Is it a function? Yes, this is a function. Why? Passes the vertical line test. Okay, so let's go ahead and write that out. Yes, passes the vertical line test. All right. Let's go to number 3. It says, what function can be used to relate the monthly bill to the number of text messages when x is greater than 500? You will see this question on PSAT on October 16th. You'll see it in SAT. Okay? And it's the one that most people struggle with. This is a linear y equals mx plus b, but a lot of people struggle with it. And the reason why is because of that. Okay, here we go. We learn in Algebra 1 this equation. We refine it, we move stuff around. And because of physics and like calculus, we change it to something that looks like this. Because this is easier to understand that I'm starting right here. The change that happens to all of this will ultimately give me an answer result of what happened. You with me? So I start at B, I add the change. It'd be like you starting your, let's say your 11th grade year at, let's say, 5'10". But then the change, you grew 4 inches or whatever, the y would show what you would get at the end. Okay? Just so that you understand why we put it in that notation. Now, y will equal to, guys, where do I start with this problem that we just did? Where would I start? 2990. Now, if you can understand what I'm explaining, these are cake. They're not that difficult. Okay, but I'm not even kidding. When I was sitting where you were at, they were difficult for me. But I didn't get it explained to me this way, okay? So 2990, can someone tell me what the slope is on this equation? 10 cents. Or yeah, 0.10. That's how much it's jumping that's how much it's changing each jump. That's what rate of change means. The change each jump. And now, most of us would put an X and we call it a day. But that's not what this is asking. This is asking specifically past the 500. Alright, back to it. So, 10 cents for the jump, but now we're talking about past the 500 texts. Okay? So now, what I'm about to show you, it's because of what I've underlined when x is greater than 500, and I want you to think of two numbers, and it'll help explain why I'm doing what I'm doing, okay? I'm going to put x minus 500 because of these two numbers. Because of 500 and because of 501. Because look, if x equals 500, what does this equal? 0. And if I multiply that with 10, what would this equal? 0. So at 500, I'm at 2990. That's called my initial value. So when my input zeroes out. Now, if I put 501 right here, what would this give me? 1. That's my first text that this now matters. Because it's that 10 cents more added to the 29.90. Do you understand? So now look, The answer is this. I don't want them to get you with SAT, but they'll try. Because what they'll do is, none of the A, B, C, or D answers have this. What they do is they will camouflage this because they distribute. Look what I'm doing. They're distributing this 10 cents to make it plus 0.10x. And a positive 10 cents times a negative 500 is a negative 50. I still have 29.90. And if I combine like terms, this equation will become 0.10x minus 2010. Now look, this right here that I'm boxing is the same equation as this. Just one looks like it's in point slope form or with parentheses, and the other one looks like what you learned in Algebra 1. But they both mean the same thing. Okay? Now, number 4 says, explain why this function, the function that we just found, either of them, cannot be used for values between 0 and 500. You can't use this for between 0 and 500. You can use it for after, but you can't between 0 and 500. Why? Okay, I heard it. Because if I put something between 0 and 500, you're going to get a negative answer. That doesn't make sense. Like, the phone company is not going to owe you money right off the bat. Okay? Please understand the way this is worded and what you're looking for. So you'd get a negative output, which is wrong. Okay? And the way you can see it, guys, be honest, is the blue one easier or is the green one easier to set up from reading? The blue all day. But for number 4, which one's easier to interpret that it won't work? The green one. Because let's say I put 0 for x on this green one. It would say that my bill was negative $20. That doesn't make sense. Okay? The equation represents everything when x is greater than 500. Okay, let's move forward. Our next part is the main piece, pun intended, as far as what we're doing today. Alright, we are looking at piecewise defined functions. Now I'm going to try to relate this to something that you might kind of experience on a daily basis so that hopefully you can understand it very clearly. Now, the questions that I got asked during Eagle Time today show me that there might be a lot of gaps in Algebra 1. Okay, I know it's been 2 years since you've done Algebra 1, but at the same time, you can't forget how to, let's say, draw lines without a calculator. Okay, that's got to come back. Okay, so here we go. I'm going to show you and I'm going to help you out as far as how to recall that right now in these notes. So it says a piecewise defined function is a function that uses different formulas or rules, which would be right here, like here and here, on what values of x are being used. Here's the intervals, here are the intervals, and here are the intervals. Okay, let this start soaking in, because this can get a little bit intimidating at first if you don't organize what's going on. Alright, here we go. If I asked you to draw this function right here by hand with no calculator, what you should do is you would go to a graph at 4, the y-intercept would be 4, and then you would have a slope of 1. That's up 1 over 1, up 1 over 1. And it would look like this. You learned how to do this in Algebra 1. What we're adding it to now in Algebra 2 is where are you going to actually draw? You're not going to draw it everywhere. you're only going to draw, look at this very carefully, when x is less than 0. So you learn domain for a reason, because if you know that x is less than 0, that means you're only going to draw. Let me erase the pieces that you won't draw. You will only put an open dot at 0 and you would draw to the left. Why? Because this told you what to draw. The analogy that I use that seemed to help a lot of people is this. A lot of people take selfies every day. If this is my selfie of x plus 4, right, what I drew at the beginning, but this right here is my edit feature, because I like to crop photos or whatever. I don't want to show everything on that photo. And if I like to crop it, that's what's going to show up on your posting on social media. Okay? So the domain is all about cutting it and reducing it to just what you want it to show. Not the entire function, but a smidgen or a piece of it. You with me? A piece of it. Okay? All right, here we go. Oh man, I do a lot. All right, let's do the next function. This next function, let's go to the calculator. Because some of us might know, very few of us do, there are functions on your homework that you may need to look at a graphing calculator or make a table for it. I'm going to show you that real quick. Negative x plus 4, negative x squared plus 4. Follow me carefully. In our calculator, I want you to soft mouse, and you can click on 1.2. Or guys, to go back and forth real fast, press Control left, Control right. Okay. No worries, just follow along, okay? Here we go. Negative x squared, and it's going to be plus 4. Follow me. So negative is the button underneath 3. Please do not put a minus, because there's a big mistake between those and sometimes it won't work. So negative x squared is next to this 4. And we're going to do plus 4. And we're going to press enter. So there's our graph. Basically, this is the snap, or this is the picture that we took. We haven't edited yet. This is just the selfie. Okay? So if this is the graph, over here it looks like let me highlight what it would have looked like. It would have looked like this, with an arrow and an arrow. Okay? But we're going to crop it. We're going to crop it to where it will only display everything that is x is greater than or equal to 0. That means all of this piece to the left is going to erase, because that's not x is greater than or equal to 0. Okay? So we're talking about x is greater than or equal to 0. We're talking about it's shading all of this stuff. Okay? Now, greater than or equal to 0. You tell me. At x is equal to 0, real quick, that's still blue. It's open. Bless you. Let's go to the right. At x is equal to 0, will it be colored in or will it be open? It would be colored in, yeah, because it's equal to. So colored in, going to the right, there's your function. Real quick recap. Is this discontinuous or continuous as you see it right now? Continuous. Nice. So there's no breaks, and this has arrows. Okay? Let's go on and move over here. So, we have 5. Don't let this confuse you. This is the same as y equals 5. Okay? So, this is y equals x plus 4. This is y equals negative x squared plus 4. This is y equals 5, and this is y equals x plus 1. So at y equals 5, it's going to look like this. A line that is at 5 that goes forever to the left, forever to the right. You just took your selfie. But now I'm going to crop it. I'm going to edit it. I only want to show the world my picture between -4 and 2. Okay? So between -4, which means I'll erase all that, all the way to 2, which means I'll erase all of that. And you see that's what we just drew. It's already drawn there for us. Okay? The last one, then we'll go to numbers. X plus 1 is this line. Just took the selfie. But we're going to crop it. We only want to draw everything where it's greater than 2. So that means we're going to erase all of this. And this right here will end up being open. Okay. Little warning right here. Am I accounting for 2? Listen, at x equals 2, am I accounting for a point here and here, yes or no? No, just 1. So that means I'm passing the vertical line test. You with me? Let me show you what that looks like over here on these intervals. At 2, look at this. One of them is touching 2. The other one is not touching 2. I'm passing the vertical line test. You with me? Because if I had both of them say equal, what would happen? It wouldn't be a function. I'd fail the vertical line test. Okay? Alright. So, now that we have that done, I think you're good to go. What we're going to do now is see how do we read these things with numbers. Okay, so first of all, we need to look at the domain that's established for these graphs. We have one between 0 and 5, and the other one that's bigger than 5. You may need to do this on your homework. If you do, it will make things easier for you, okay? What I'm going to do right now is I'm going to draw this interval right here. Here we go. So from 0 to 5, it includes 0, it includes 5, and it's everything in the middle. You with me? This is the domain between 0 and 5. Now I'm going to do the other interval, okay, right here, where x is bigger than 5. So let's put 5 here. It's like we're stacking them on top, but we're going to say bigger than 5. Do you see what I just did? Yeah. Okay, visual representation of the actual inequality domains that they listed. And it still passes the vertical line test. You can even see it. Perfect. Nice. Thank you for mentioning that. Right there, it passes the vertical line test. Okay, here we go. Now, I'm going to take this one and I'm going to plug it into which function? Which one? Not x. Which function am I going to plug 1 into?
3x plus 5.
P. Okay, some of you might be jumping a little bit ahead. I'm just jumping it into function P. On your quiz that you'll have in 2 classes, it's not going to, you're not just going to have one function there. You could have 2 or 3 functions there. You have to know which one to plug it into. So we're going to plug it into this function. Okay? Like this right here. We're not using this one is what I'm trying to tell you. Okay. So now that you know you're plugging it into P of x, piecewise defined functions tell us which equation are we going to plug it into. We have to pick which machine. It's like standing in front of 3 different vending machines. Which one am I going to plug this into? Okay? So, together, 1 is right here. Do you agree? Yeah. So, it's going to be using this domain. That means we're going to use this function. That's how we know which machine to plug it into. And I'm going to plug it in where I see x. And the work that I want you to show is this. So 3 times something plus 5, and we're going to plug in 1. So, because 1 existed in that domain.
Oh, okay.
Okay? That told us, I'm going to use this machine. Yes?
So, are we ever going to have a situation where the
Okay, wait for it. I know what you're thinking. Wait for it, okay? It's coming. I just don't want you to steal the thunder. Here you go. Now, what am I going to get, guys? 3 times 1 plus 5? 8. So, P of 1 is 8. Please show the work. When I'm grading your stuff is different than when you're grading your homework, okay? I need to see work. It needs to be neat. I need to be able to follow to give you as much partial credit that I can, okay? But if you just put P of 1 is equal to 9, I might have to take off minus 4. You know what I mean? I need to see the work. All right, here we go. We're still working with P, but this time we're going to plug in 5. You have to find which equation am I going to plug it into because it's 5. You tell me which one. First, second, or third? First one. Because it's equal to. Okay? So, oh yeah, there's no third one on this. My bad. All right. So this would be 3 parentheses plus 5. But this time we're going to plug in 5. What do I get? 20.
What?
15 plus 5.
I'm so sorry.
It's okay.
Thinking of one.
All right, here we go. Next one says P of 10. Looking at these 2 intervals, the second one. So let's build the equation. It'll be something squared minus 3. We're going to plug in 10. Anyone, what do I get? 97. So P of 10 is 97. All right. Look at the next one. We're still plugging into P. But this time we're going to plug in a negative 6. I'm already there. There's nowhere that we can plug this into. So you just say, you don't leave it blank, you're going to say that you can't define it. So piecewise defined function, if you can't define it, you're going to put undefined. This is not dividing by 0 undefined. It's something a little bit different, but we still use undefined. Okay? So let's put undefined. Question? You're going to compete here in just a bit. I just want to make sure you're solid as far as what you need with those tools. And the progression that we're going through, guys, awesome time too. Yes?
Are we ever going to have a situation where both, like, let's say the 5, let's say, like, it's a 5, and then it's like, they're both line.
Okay, do you hear what he's asking? He's saying, will we ever have, let's say that we're asking this question right here. Here's what I'll say. If you find it, and it's on a quiz or on a test, I'll give you a lot of bonus points. Because it was poorly written by us. But what he's asking is this. Will we ever be asked to solve for something that looks like P of 5 if we have an equals to here and an equals to there? We will not. Because you don't know where to go. And it would fail the vertical line test because you have 2 y values and the same x. I hope you're starting to put all this together, okay? All right, let's do the next one. This time I'm not going to draw those pictures as far as these pictures right here. I'm not going to draw this. I want you to imagine this. I want you to envision based off what you see here, here, and here. Okay? Here we go. We are going to use f of x. We're going to plug in 0. Don't say anything yet. You have 1, 2, 3 equations. Look at those interval notations because you need the practice. And you tell me, where does 0 go? The second one. Nice. 0 belongs between -4 and 3. So that tells us we're going to use this equation right here. What are we going to plug in? 0. What do we get? 10. So f of 0 is 10. You learned this way back when in Algebra 1 as 0, 10 as a point. But this is Algebra 2. We're notating it like this. Okay? Alright. Let's go to input. X is 3. Careful. It's the last one. It's the last one because it's equal to 3. So we're going to use the third equation. So let's build it. We have 2 times something minus x. We are plugging in this 3. What do I get? 0, right? No, you're right. You got 6, but 6 minus 6 would give you 0. So you get f of 3 is 0. Okay, let's do 2 more. F of negative 100. Guys, 1, 2, or 3? 1. Now look at this carefully. I'm going to do it in a different color. Well, there's different colors everywhere. Let's do just 8. Now there's no parentheses. The first one, I use parentheses here because of that variable here. This one I use parentheses because of that variable there. But this third one that I'm working with, there's no x anywhere. It's just 8. So can you actually plug in a negative 100 into anything right now? No. So what's left? 8. So f of negative 100 is 8. And last but not least, we're going to plug this into the last equation. And it's going to be 2 parentheses minus 6. And when we plug in this 100, you should get 197. So f of 100, or 194, thank you, is 194. Questions? Good? All right. So, this next question, if you can do it, the quiz is easy. Okay? So, we're going to do a real-world problem with a piecewise defined function from what we read. There is a twist to this question, so pay attention closely. But the twist won't happen on the quiz and it won't happen on the test because we will word it better. The ones who wrote this didn't word it as well, and that's why there's a little bit of inconsistency. But I want you to see it. Okay? Here we go. Determine a piecewise function based on the description provided. You determine your tax credit, C, based off of your annual salary, A. So if your annual salary is below $24,000, what does that look like? If you're using letters, and I say your annual salary is below $24,000, what would you write and where would you write it?
Or I mean, you put X is less than 6,000. Nothing equals to 2,000.
Okay, so look, I heard both of them. I heard X,
Oh, it's X.
and I heard A.
A.
We're going to use A because our input variable is A. But then I heard both of them. I heard less than or equal to. We're going to talk about this. And I heard less than. From what you read right now, I say it should be less than. So let's do that together so far. A is less than 24,000. Okay? Now we're going to put commas because you have the function column right here. And then you have the domains. Okay? Now, what we just wrote was this right here. Below 24,000. Next one says between 24,000 and 50,000. So, I'm telling you right now, if you see something that's in between two numbers, the default is don't include them. Do not include them with brackets. If you say between and just between, think of it as parentheses. But if it says between inclusive or including, then you put brackets. You with me? But if it just says between, I want you to think parentheses. They don't touch those numbers. Alright, so here we go. And that's the big thing that I'm wanting you to see because it'll help you figure out everything else. between 24,000 and 50,000. See, this last one says if you make 50,000 or more. Go ahead. We'll get to that. I think I know what you're talking about. We'll get to it, okay? Just wait up on it. Just a little bit more. 50,000 or more is going to be A is greater than or equal to 50,000. I think, if I'm correct, maybe Powell was thinking about this just now. The first one had A is less than 24,000. The second one has A is greater than this 24,000. We never included 24,000. And that's the twist on this question. You won't see something worded this way incorrectly. On the quiz and test, it will be clear, okay, of where it goes. But on this one, because of what I highlighted here in green, I would go and change this to be equal to, and I want you to do that. I know what it says, I know what it reads, but I want you to change it because of what I told you the default of between means. Okay? Alright, so it's almost like saying 24 or below. Equal to 24,000 or below. Alright. Now guys, if it's less than or equal to 24,000, it says your tax credit is going to be 25% of your salary. Let's use math. How do I show 25% of a salary?
Times 0.25.
What times 0.25? A. So here we go. 0.25 times A. The next one says 20%. What was that? Alright, so back. The next one says 20% of the salary. What do I write? 0.20 times A. And the last one is 14%. Alright, going back to it. 14% of A would be 0.14 times A. We've just read this whole paragraph. You will have one on your quiz, not next class, but the one after that. It's something like this, so please make sure that you are looking over this. But what I want to explain now is where the point systems come into play. Now listen carefully. Some of your answers may be different, but whatever you write, you must pass the vertical line test. I gave you a little bit of a hint. Whatever you choose to write, you must pass the vertical line test. I want you on your paper to put arrows because that's what you've been taught. If there's nothing there, it's going to be assumed to be an arrow. And you have three functions. Some of yours will be different, but you must be consistent with what you choose, and you cannot fail the vertical line test. And then you'll have domains. You have 6 different pieces that you will get credit for as a team. Only what you agree upon as a team can you submit as an answer. You can't say, okay, one of us had it, so we'll get points. You must all agree, and you're going to say, we turn this one in. You'll get 10 points for each of those highlights. If you get all 6, I'll double your score to 120. Okay? You have 6 minutes to work together, starting now. Okay, so the way we're going to do this, we're going to refer back to Algebra 1. This first piece, the way I would concentrate on this, and I'm recording this to help you with your homework right now. This first piece is right here, and to me, it's graphed everywhere from negative infinity all the way to 2. Okay, here we go. I would say x's that are less than or equal to 2. Before you start saying anything, some of you might have said x's that are less than 2, and that's okay as well. Okay? Because some of you are not including 2, some of you are including 2. You just have to be consistent throughout the rest, and I'll get to that in a minute. Now, what is this equation of the line? The way I want you thinking about it is what you learned back in Algebra 1. I would look at this line. I would find on the y-axis that it started at 1, and the slope is up 1. Whoops. up 2 over 1. And there's another corner that I got to. So the slope is 2, the rise over run, and the y-intercept is 1. And you learned back in Algebra 1, that would look like this. So everyone should have 2x plus 1 right here. Okay, let's keep going. This second interval is going to be between 2 and 5. And please don't talk too much because I want people to hear the recording. So from 2 to 5, you might have chosen different things. I'm going to give you 2 options that you could have. There's even a third option. You could have written between 2 and 5 like this. Now, let me do it correctly with red so that you can match up red with red. Between 2 and 5. Notice that I did not double dip 2 or double account for 2. I'm passing the vertical line test right now. Okay? And you can see that right here and there. You with me? I'm passing that vertical line test. However, if you chose this thing that you put in black, that I put in black right here, you would have to put something like this. You have to account for 2 here since you didn't account for 2 there. Okay? Because it's continuous. Let's keep going. Oh, real quick. This function is y equals 5. So you would write 5. The last one is going to be from 5 to infinity. And if I'm going with what I have in red, it'd be greater than or equal to 5. If I'm going with what I have in black, it would be greater than 5. Because I'm not going to fail the vertical line test by double dipping and having 2 equals on 2 different places like that. Now this one is a little bit tricky. So we learned it back in Algebra 1. Let me quickly review on how to get it. I see a rise over run, down 1 over 1. Down 1 over 1. Down 1 over 1 to the right. That's why it's positive. So slope is negative 1. You with me? Now, this will go all the way to 10. And because this has a slope of 1, it will also go all the way to what? 10. It'll go all the way from 10 down to 10 because the slope is 1, negative 1. Okay? So what this function should have been is a y-intercept at 10, but a slope of negative 1. Now, I want you to count them up. You have 6 different pieces. This is it for notes.